Well, hello everybody, and welcome to the beginning of Chapter 3. While some of you are taking your test, others of you will be watching these notes here in video form, hopefully. Uh, and today we're going to start with 3.1. We're talking about the basic properties that allow us to work with equations. We're going to start solving some stuff here. So we'll start with addition and subtraction, and you can see we'll talk about these properties. We'll do a few examples. We're not going to do all 10 for each one. We'll probably do 5 or 6. Then we'll talk about multiplication and division, and we'll do the same thing. Okay, so let's get rolling here. We're talking about transforming equations. When I say transform, what I mean is the steps you would take to solve it, okay? So the first couple that we're going to talk about, we're going to talk about the addition property of equality, and you use this all the time. Basically, the way we'll define the addition property of equality is we'll say if A equals B, so you've got two equivalent things, then A plus C equals B plus C. Meaning, you can add this something C to both sides, and as long as it's the same thing, then your equations should stay equal. And this is something we use all the time, right? How often have you gotten somewhere like you've got x minus 2 equals 7, and you say, oh, well, I know to solve that. You add 2 to both sides. That is the addition property of equality. So we would say the outcome would be x equals 9. Okay, so that's something we use all the time. It should look pretty familiar, but this is in the blue is how we would define that. The subtraction property of equality says something very similar. Same idea. If A equals B, so we've got an equivalent statement here, then we'll say, well, then A minus C equals B minus C. Right? So same idea, but we're subtracting something from both sides. And again, we use this all the time in equations too. Let's say if this is x plus 2 equals 7. Well, then we'd say, oh, well, I know that I can subtract the same thing from both sides, and the outcome would be, well, then x equals 5. So the addition property is what allows you to say that you can add the same thing to both sides of an equation and it stays equal. And the subtraction property of equality is the same idea, but you can subtract something from both sides and it will stay equal. Period. Don't forget that. Okay. The next thing here, it says, why would the subtraction property of equality be considered a special case of the addition property of equality? And that's absolutely a valid question. Technically speaking, the subtraction property of equality, many people consider it to not be a thing because if you're subtracting, all you're really doing is just adding a negative. So you're still adding, really, you're just adding a negative. You're really just adding a negative. There we go. Very good. Okay, the last little thing before we start doing some examples, equivalent equations are equations with the same solution set. Meaning, if you follow these rules, these properties, you should keep your equations equivalent, and therefore you should not change the solution at any point in solving the equation. And that's the whole idea here is we're transforming these equations, but we're keeping them equivalent so that when we get to the end and we see our solution, we know that that's the same solution as our initial equation. So here we go. When solving equations, we are simply performing transformations that produce equivalent equations until we end up with an equation that makes the solution set obvious, right? We get something like x equals blank. The transformations we'll use today, one, the same stuff we talked about in units 1 and 2. We're going to simplify if there's any simplifying to be done, right? Can we combine like terms? Can we distribute anything? And then we're going to use these addition and subtraction properties of equality in no particular order. It does not matter which one comes first. You'll find more often than not that you do one and not the other. Okay, so let's take a look here at number 1. And it says for the example, solve the equation. And then also show all your steps and check your answer. That's going to be important. I am going to ask you to check your answer and show me that you checked your answer for these first couple homework assignments. So if we're looking at this first one, we've got x minus 8 equals 17. And remember, we're trying to isolate the x. So in order to get the x by itself, well, if we've got minus 8 over here, well, the addition property of equality says, well, we can add 8 to both sides, and we should have an equivalent equation. So if we add 8 to both sides, well, on this side, they cancel, and we're left with just x equals 17 plus 8 is 25. And that is your solution. Now check it, right? If you do 25, you plug the 25 in for x, If you do 25 minus 8, does that give you 17? Well, 25 minus 8 is 17, and 17 is equal to 17. So we have checked. We're good. Okay, moving on. Number 2. Negative 5 equals n plus 13. Well, in this case, again, we're trying to isolate the n. It's not always going to be an x. So to do that, well, we see, well, it's n plus 13. So if we can subtract 13 from both sides, we'll be feeling pretty good. Negative 5 minus 13 is negative 18. N plus 13 minus 13, your 13s cancel, equals n. Your final answer, we should put the variable on the left, so flip-flop that, n equals negative 18. And there you have it. That's the symmetric property at work, my friends. And if you check that, negative 5 equals negative 18 plus 13. And if you do negative 18 plus 13, you do indeed end up with negative 5. Check. We're good. And there you go. Moving on. This next one, negative 4 plus y equals 0. Again, we're trying to isolate the y. And well, if we've got this, well, we want to add 4 to both sides in order to isolate our y. Your negative 4s on this side cancel to give you y equals, and 0 plus 4 is 4. We should hopefully be feeling pretty good now. And if you check that, negative 4 plus 4 equals 0. Well, negative 4 plus 4 is indeed 0. Check, check, check. Okay, I'm going to let you take a look at 4, 5, and 6 on your own here. And we're going to take a look at 7, 8, and 9 because they're a little bit more complicated. And then I'll let you take a look at 10 on your own as well. Hopefully this stuff is feeling old news, easy peasy. That's the goal here. So this one here, we're trying to isolate our m, okay? And so in order to do that, we're going to subtract 5 from both sides. So if you subtract 5 here, well, these 5s cancel. But notice this time that that's going to leave you with a negative m equals negative 5 minus 5 is negative 10. Here's the deal, though. I don't want to know what negative m equals. I want to know what m equals. Well, if negative m equals negative 10, let's just use a little bit of logic on this one before we jump into what will inevitably be discussed in our multiplication and division properties. But hopefully we see, well, if negative m equals negative 10, then m hopefully equals 10. And that is indeed the case. Okay, and if we check that, 5 minus 10, is that equal to negative 5? Well, 5 minus 10 is indeed negative 5. Check. Bing, bing, boom. Sweet. So now we're getting into some ones where we can actually do a little simplifying first. So that's always going to be step 1. Remember, by the associative property of addition, just because the c plus 2, whoa, hello. One moment, please. Just because the c plus 2 is in parentheses doesn't mean we can't switch where we want the parentheses. So I could instead write this as c plus 2 plus 8 and put the 2 plus 8 in parentheses equals 4. And we get c plus 10 equals 4. So now I've simplified. I've combined my like terms. Now I say, oh, well, that's easy peasy. I know I should subtract 10 from both sides, and we get c equals negative 6. Don't forget to check, right? If I plug in negative 6 plus 2 in parentheses plus 8, is that equal to 4? Well, negative 6 plus 2 is negative 4. Plus 8, is that equal to 4? And yes, that is equal to 4. Very good. Moving on to our last example for addition and subtraction here. We have 1 equals negative 2 minus 4 minus w. Well, just like we talked about in the last unit, 1 equals, let's simplify first. Remember, this negative 2 is really a negative 1, so let's distribute the negative 1 through. So we get negative 2 minus 4 plus w. And then we can combine some like terms, right? 1 equals negative 2 minus 4 is negative 6 plus w. And now we say, okay, well, if I'm trying to isolate the w, I should add 6 to both sides. Don't forget, we're adding the 6, right? And our 6s are going to cancel out. We get 7 equals w, or better yet, w equals 7. Don't forget to check your work. 1 equals negative 2 minus 4 minus 7. Well, that's going to be 1 equals negative 2 minus negative 3, right? 4 minus 7 is negative 3. And if you're subtracting a negative 3, this is really 1 equals negative 2 plus 3, which is 1 equals 1. Check. Very good. So again, I'm going to let you take a look at 4, 5, 6, and 10 on your own. They will be filled in on the note sheet when you come back and look, but those are ones that I want you to just copy so we can move on to multiplication and division. Same idea here. The multiplication property of equality says that if A equals B, then you can multiply both sides by the same thing, C, so A times C should be equal to B times C, and that stays equivalent. So for example, if you have something like x over 2 equals 6, right? The way we would solve this is say, oh, well, we multiply both sides by 2, and we get that the outcome is x equals 12, right? That's the multiplication property of equality. The division property of equality is the opposite, right? So if A equals B, and we use this one a lot, then you can divide both sides by that same thing, C. So A over C should be equal to B over C. And there you go. You see this all the time with something like, well, 2x equals 6. We would divide both sides by 2. Let me do this in red like the other stuff. If 2x equals 6, divide both sides by 2, and we get that x equals 3. We see that all the time, right? So it's saying you can multiply or divide both sides of your equation by the same thing, and you are good to go. Same thing here when we're solving these equations. Same idea. We're transforming them using multiplication or division. These are all pretty much one-step equations. Sometimes you have to simplify a little bit first, but then you're really just taking one step of solving. So again, simplify if you can. Take that one step. Done and done. So this first one, I've got 8x equals 16. Hopefully you're saying, well, if it's 8 times x equals 16, how do I undo that 8? Oh, I'm going to divide both sides by 8. Boop. And we get x equals 16 divided by 8 is 2. Done and done. Don't forget to check it. Is 8 times 2 equal to 16? It sure is. 16 equals 16. Check. 1/2 b equals 24. 1/2 b equals 24. Well, this is one where you can think of this in a couple of different ways, and this is why, similar to how addition and subtraction are essentially the same thing, if subtraction is just adding a negative, hopefully we recognize that dividing is just multiplying by the reciprocal. So you can kind of handle this a couple different ways. You can either think of it as dividing by 1/2 on both sides, but hopefully you recognize that if you're dividing by 1/2, what you're really doing is multiplying by 2 over 1, right? If you're dividing, you're really multiplying by the reciprocal, and that's going to be the easier way of thinking about this, is you're really multiplying by 2 over 1, right? Your 2 over 1 over here cancels your 1/2 to leave you with just b equals 24 times 2 over 1, or 24 over 1 times 2 over 1 is 48 over 1, or 48. And again, if you double check your work, 1/2 of 48, is that equal to 24? Well, half of 48 is 24, so we're good. Good stuff. So this one looks a little different. N divided by -5 equals 4. Hopefully you recognize, well, this is the exact same thing. N divided by -5 is the exact same thing as N over -5, which is how we're more accustomed to seeing it, equals 4. And you say, oh, well, if I'm dividing by -5, to undo that, I need to multiply both sides by -5. Boom, boom, those cancel, and we get N equals 4 times -5 is -20. Don't forget to check, right? If you do -20 divided by -5, is that equal to 4? Well, yes. -20 divided by -5 is 4, which is equal to 4. Good to go. Don't forget to check your work. There's really no excuse for missing a problem about equations, because it's so easy to check. Just plug it back into the original equation and you're good to go. Okay, so this one, remember the idea here, we're trying to isolate the t, so we want to, it's -2/3 times t, so in theory we're dividing by -2/3, but again, hopefully we remember, if we're dividing by a fraction, the much easier way of thinking about that is we just want to multiply the whole thing by the reciprocal, so times -3 over 2, and we're going to do that over here too, -3 over 2 times 8. So, and I'll write this out just so it's a little clearer, but we've got -3 over 2 times 8 over 1. So it's a little easier to see. Should equal, these guys are going to cancel. So t. Well, let's cross simplify this now. Hopefully we're getting in the habit of doing that, realizing that Mr. Kaplan wasn't wrong when he said that's usually easier. 8 and 2 have a 2 in common, so 2 divided by 2 is 1. 8 divided by 2 is 4, and we end up with negative 3 over 1 times 4 over 1, so negative 12 equals t, or better yet, t equals negative 12. You can, generally speaking, skip this step. You don't have to show me that, but I'm just showing it to you for the notes here. Don't forget to check your work. If you have 8, is that equal to negative 2/3 times negative 12, or 12 over 1, we'll say? Well, yeah, absolutely, right? 3 and 12 have something in common. That would be a 3, so the 3 becomes a 1, and the 12, if you divide by 3, becomes a 4. And negative 2 over 1 times negative 4 over 1 is indeed 8. Beautiful. Last couple here. Trying to isolate the y, we've got 1/4 y, so hopefully you recognize, okay, we should multiply both sides by 4, or 4 over 1, right? So y equals 6 and 1/4 times 4 over 1. Before you multiply fractions, make sure everything's in proper. So 6 and 1/4, right? 6 times 4 is 24, plus 1 is 25. So this is really 25/4 times 4 over 1. Hopefully you recognize, oh, look at that. Your 4's are going to cancel. You get that y is equal to 25. Okay, and if you do that, 1/4 times 25, is that equal to 6 and 1/4? Well, this is 25/4 equals 6 and 1/4, and we just said, yes, 25/4 is 6 and 1/4. Sweet. Okay, moving on. Last one. All right, last one. And this one's not too challenging, but it is something from last unit that I want us to remember. Trying to isolate the u, hopefully you say, oh, well, this is negative 4.5 times u equals 0. Divide both sides by negative 4.5. And then you say, oh, well, 0 divided by anything is 0, Mr. Kaplan. And I say, way to go, guys. Yeah, it's absolutely 0. So u equals 0. Great. And if you check your work, you get that negative 4.5 times 0 equals 0. Well, that's absolutely true, because anything times 0 is 0. Done and done. Again, for this one, you're going to take a look at 4, 7, 8, and 10 on your own. Take a look at those, and you should be good. Don't forget to tackle the 3.1 homework. Don't forget to check your solution on all of these, right? I will be checking for that. And other than that, I hope that you found this to be a lot of review. We'll build on it starting next time. So I hope you took these notes, and thank you all so much.